Welcome to the A320 Pressurization System lesson. In this lesson, you will gain a basic understanding of how the pressurization system operates. You will also learn how to control and monitor the pressurization system using its associated overhead panels and the SD. The pressurization system controls cabin pressure to ensure a comfortable and safe environment for the crew members and passengers. All areas of the aircraft are pressurized except for the following: the radome, the landing gear bays, the air conditioning compartment, and the tail. Pressurization is automatically maintained by one of two pressurization controllers. Each controller operates an electric motor which opens and closes an outflow valve. The outflow valve regulates the amount of air allowed to escape from the pressurized areas. During normal operations, entries made to the multifunction control and display units provide for automatic pressurization control. The overhead cabin pressurization panel is used for addressing non-normal conditions. The pressurization system may be monitored by referencing the cruise and cabin pressurization pages. The pressurization system is controlled by two independent pressurization controllers. Only one serves as active while the other remains in standby. In the automatic mode, the active controller receives data from several sources. This data is then used to calculate a pressurization profile. To maintain the profile, the active controller sends commands to an electric motor, which opens and closes the outflow valve as necessary. Shortly after landing, the active and standby controllers automatically swap roles. During flight, if the active controller fails, the standby controller automatically takes over without any degradation to system operation. If both controllers fail, the system can be transferred to manual operations by selecting the Mode Select push button. The status of the two pressurization controllers is displayed on the cabin pressurization page. System 1 indicates the current active controller. The active and standby controllers can also be swapped manually by placing the Mode Select push button in the manual position for 10 seconds. Select the Mode Select push button to manual. Notice MAN illuminates in the push button, and MAN replaces System 1 on the cabin pressurization page. Also, being pressurization is currently in the manual mode, Auto and the landing field elevation have been removed from the cabin pressurization page. The outflow valve is now exclusively controlled by using the manual vertical speed control switch. To return to Auto, press the Mode Select push button again. Notice the controllers have swapped roles. System 2 is now the active pressurization controller. On a typical flight, the active pressurization controller uses input from several aircraft systems to calculate a pressurization profile and control the outflow valve. The controller not only knows the current status of the system, but it can predict future needs as the flight progresses. This enables the pressurization controller to properly control the outflow valve appropriate for the current phase of flight. Pressurization controller input includes flight management system information such as planned cruise altitude, estimated time to reach cruise altitude, and estimated time to top of descent. Feedback from the thrust levers to signal when takeoff roll is initiated. Data from the Air Data Inertial Reference System, or ADIRS, such as rate of vertical speed and current altitude. And information from the Landing Gear Control and Interface Units, or LGCIUs, which tell the controllers if the aircraft is on the ground or in the air. One of the most important inputs to the controllers is the destination airport elevation. The controllers receive this information from the Flight Management and Guidance Computers, or FMGCs, when the landing elevation selector is set to auto. By reviewing the cabin pressurization page, you can verify that landing elevation is in auto. Once a destination airport is entered, the landing elevation is automatically entered into the pressurization system. Notice the field elevation for Chicago O'Hare is now displayed on the cabin pressurization page. Landing elevation can also be set manually by the pilots. By pulling the landing elevation selector out and dialing it against the outer scale, the landing field elevation is then entered manually. The scale is graduated in thousands of feet. For example, to manually enter a landing field elevation of 2,000 feet, rotate the selector to 2. Manually setting the landing field elevation would be performed due to both FMGCs failing, or the intended airport of landing is not in the FMGC database. The outflow valve is located on the right side of the fuselage, behind the aft cargo compartment and below the flotation line. Status of the valve is displayed on the cabin pressurization page. Normally, the outflow valve actuator is automatically driven by either System 1 or System 2. It can also be manually driven by a separate motor when necessary. This is performed through the use of the Mode Select push button and the manual vertical speed control switch. To manually drive the outflow valve, select the Mode Select push button to manual. Next, you use the manual vertical speed control switch to open or close the outflow valve. Up opens the outflow valve, and down closes it. Two safety valves are installed in the aft bulkhead above the flotation line. The safety valves open and close automatically when preset thresholds are reached to avoid excessive positive or negative cabin pressure differentials. The cabin pressurization page displays a single safety valve icon that represents both safety valves. Normally, the safety valves are closed and the icon is green. If either of the safety valves open, the indication changes to amber. The ditching push button, located on the overhead cabin pressurization panel, is used to close all fuselage openings below the flotation line. These openings include the outflow valve, the emergency ram air inlet, the avionics ventilation inlet valve, the avionics ventilation extract valve, and the pack flow control valves. Cabin differential pressure, or delta P, is displayed on the cabin pressurization page in a digital and analog format. This readout represents the PSI difference between internal cabin pressure and external pressure. The analog and digital cabin vertical speed indication displays the rate of change of cabin altitude in feet per minute. The cabin altitude indication displays the current cabin altitude in analog and digital formats. Pressurization information is also presented on the cruise page. The cruise page displays some of the same pressurization information as the cabin pressurization page in a smaller format. One exception is when the manual mode is selected. When operating in the manual mode, an analog presentation of cabin vertical speed is displayed. This indication is very useful since you can continue to use the cruise page while operating in the manual mode. During normal operations, the system functions using one of 6 pressurization modes depending on the phase of flight. Whenever the aircraft is on the ground mode is active and the outflow valve is commanded fully open. The pressurization system enters the takeoff mode when the thrust levers are moved to the takeoff positions of either flex or toga. The outflow valve begins to close and the aircraft pre-pressurizes to avoid any pressure surges at rotation. The pressurization system enters the climb mode after liftoff. During climb, the cabin altitude will climb in proportion to the aircraft's actual climb rate. The cruise altitude, provided by the FMS, is used by the pressurization controllers to adjust the profile accordingly. In the cruise mode, the system attempts to maintain the lowest comfortable cabin altitude without exceeding maximum cabin differential pressure. During descent, the active controller maintains the cabin descent rate to reach an altitude slightly below the landing field pressure altitude just prior to landing. For passenger comfort, the automatic function limits the rate of cabin descent to a maximum of 750 feet per minute. The active controller uses the landing elevation from the FMS database along with the current altimeter setting for the destination field to determine the target pressure altitude for arrival. The active controller optimizes the cabin pressure descent profile based on that computed pressure altitude. Upon landing, the system reverts back to the ground mode. A full open signal is sent to the outflow valve shortly after touchdown. Any residual cabin pressure is released gradually before the outflow valve is fully opened. The abort mode is used if the aircraft must return to the departure airport after takeoff. If a predetermined rate of descent is sensed below 8,000 feet, the active controller will descend the cabin to the departure airport's elevation. The abort mode is automatic and does not require any pilot action.
That is correct. That is incorrect. That is incorrect. That is incorrect. That is incorrect. That is correct. That is incorrect. That is incorrect. That is incorrect.